Failure is not treated as a possibility inside emergency medical systems. It is treated as a condition that must never exist. Because what flows through these systems is more than oxygen or power. It is time. It is margin. It is the difference between a system responding instantly and a system hesitating even for a fraction of a second. At this scale, hesitation is failure, and failure is measured in lives. Emergency medical infrastructure is designed to move as a single, continuous organism, not separate machines, not independent units. Everything is connected, balanced, aware of everything else. Each pathway, each sensor, each conduit communicates silently with the rest. Parallel pathways run side by side. Primary systems never operate alone. Redundancy is not added later. It exists from the very first decision, like a hidden layer of protection woven into the design. If one pathway weakens, another carries the load without pause. No flicker, no alarm, no visible switch, no announcement. The transition is silent, invisible, seamless. Engineers do not interact with these systems emotionally. They observe, they confirm, they verify. Their presence is not for intervention, it is for vigilance. Human hands and eyes exist to supervise stability, not to rescue failure, because rescue implies surprise, and surprise is not permitted here. What leaves this system does not vanish into abstraction. It feeds real environments, emergency wards, critical care units, spaces where interruption is unacceptable. Every patient, every procedure, every vital monitor relies on the continuous flow of power, oxygen, and information. The system is aware of these dependencies at all times, not symbolically, not as a vague concept, numerically, quantitatively. Live data confirms that what begins here continues elsewhere exactly as intended. Pressure remains constant, power never falters. No endpoint is treated as distant or optional. Every pipeline, every conduit, every microprocessor contributes to a single, uninterrupted chain of reliability. Control is not constant adjustment, it is constant readiness. The system does not wait for alarms. It watches margins, trends, subtle shifts that occur long before failure announces itself. Indicators remain within tolerance not by chance, but by deliberate design. Every value exists inside a range carefully chosen, wide enough to absorb stress, tight enough to detect drift. Early warnings do not demand reaction, they demand awareness. Redundancy does not sleep. Backup pathways remain aligned, active, synchronized. They do not power down to save energy. They remain ready to carry the full load, instantly, without hesitation. This is what failure is not an option truly means. Not perfection, preparedness, completion.
Even when part of the system is idle, the whole remains complete, ready, alive. And this discipline begins long before assembly. It begins with what is allowed to enter the system at all. No raw material is neutral. Every component carries risk until proven otherwise. Materials arrive sealed, certified, traceable. Not because trust is absent, but because trust must be measurable, documented, unbroken. Nothing enters anonymously. Every item is logged, serialized, accounted for. If its origin cannot be verified, it does not proceed. If its integrity is uncertain, it stops. There is no urgency here, only procedure. Only deliberate, measured movement. Materials are separated from the general environment immediately, handled under tightly controlled conditions, moved only when explicit permission exists. Inspection does not search for excellence, it searches for deviation. Dimensions are measured against tolerance, not expectation. Surfaces are examined not for beauty, but for imperfection. Certification marks are not decorative, they are thresholds. Approved components move forward quietly. Rejected ones are removed without discussion. Rejection is not failure, it is containment. Environmental conditions are treated as components themselves. Air quality, temperature, particulate levels, humidity. Stability is preserved not because the system is fragile, but because variability accumulates. Sensors remain active during every step. Trust is never assumed once and forgotten. It is verified continuously. Materials are staged not by convenience, but by sequence. Order matters before assembly even begins. Each component waits its turn. Nothing advances early, nothing is rushed. The final verification does not look for progress, it looks for permission. Only when every condition aligns does the system allow the next step. Assembly does not begin with motion, it begins with stillness. Tools wait, calibrated and idle. Workstations are arranged by logic, not speed. The system dictates the order. Humans follow. Components are positioned without force. Alignment guides exist to prevent interpretation. If something does not fit, it is stopped. Mounting is deliberate. Force is measured. Torque is controlled. Every connection is secured within limits that were defined long before this moment. Close enough is never accepted, only confirmed. Secondary components follow the same discipline. Connections are inspected, seals verified. Redundancy is added not as backup, but as a parallel reality. Sensor pathways are routed cleanly, visibly, predictably. Confusion is engineered out before it can appear. Data is observed before instinct is trusted. Machines correct themselves first. Humans confirm after. Once alignment is achieved, the system locks itself. No further adjustment is allowed. Completion does not invite celebration, it invites scrutiny. The assembled system does not claim readiness, it waits to be challenged. Because the system has only been built so far, it has not yet been believed. And belief in emergency medical infrastructure is earned only under pressure through testing, verification, and relentless vigilance.
Belief does not come from design documents. It comes from stress, from pressure, from repeated challenges, from conditions that would break almost any other system. Once assembly is complete, the system is isolated, not protected, not sheltered, separated so that nothing external can explain what happens next. Here, certainty replaces confidence. Here, stability is proven, not assumed. Testing does not ask if the system works, it asks how the system behaves when conditions stop being reasonable. It asks how every network of pipes, conduits, sensors, and backup power reacts when every margin is challenged. Every connection, every dependency, every microprocessor. Diagnostics activate first. Every internal signal becomes visible. Nothing is hidden behind averages or summaries. Every data point, every flow measurement, every pressure gauge is laid bare. Limits are set far beyond real-world demand, not to break the system, but to remove excuses. Every potential stress that could emerge in a hospital, an airport, or an emergency center is rehearsed here, methodically, silently, deliberately. Pressure rises slowly. Power load increases without vibration or shock. Temperature, humidity, and flow move incrementally beyond standard tolerances. The system is allowed to respond in its own time. Sensors react instantly, not emotionally, mathematically. Every fluctuation is recorded, analyzed, and verified. The system itself interprets data faster than humans ever could. As stress increases, redundancy engages silently. No alarms, no drama. Backup systems do not wait for permission. They are already synchronized, aligned, ready. Heat flows, energy shifts, pipes adjust, valves respond, power lines reconfigure. Every element reacts without hesitation. The primary system recovers without shutting down. Recovery is expected, not celebrated. Sudden spikes simulate emergencies that arrive without warning. Every protocol engages at once. Coordination replaces reaction.
Under extreme combined load, the system does not falter. Pressure, voltage, flow, they are maintained simultaneously. Endurance is measured over hours. Conditions remain harsh, margins hold. Engineers watch, but they do not intervene. Human correction under stress is not permitted. When the test concludes, load returns to normal smoothly. No residual instability, no delayed effects. The system shifts from test to readiness silently. Deployment does not feel like a launch. It feels like a handoff. The system is sealed, certified, digitally acknowledged. Readiness indicators activate quietly. Silence is intentional. Connection to external infrastructure happens without disruption. The transition is seamless. Remote endpoints confirm integration. The system now extends beyond the factory walls. Hospitals, emergency centers, airports, all receive continuous supply without a single hesitation. When it goes live, nothing remarkable happens. No alarms, no fluctuations, no visible effort. Oxygen flows steadily. Emergency power remains stable. Data returns continuously. Downstream systems function normally. Redundant backups remain on standby, ready but unused. Night cycles change nothing. Human presence becomes optional. The system corrects itself silently. Micro adjustments occur without notice. Every dependency functions exactly as designed. Control rooms remain calm. Logs update continuously. Monitoring replaces intervention. Shift changes occur without disruption. Personnel rotate, the system does not. Over time, it blends into the background. Reliability becomes invisible. Nothing happening becomes the highest achievement. Every component is tested, every dependency verified, every possible failure rehearsed. No action is needed because preparation has already anticipated it. The system works not for observation, it works for consequence. It works for the lives that depend on it, silently, without acknowledgement. Even when humans leave the room, the system persists. It remains unchanged, stable, continuous. Time itself is measured not by the system, but by the way it continues, minute after minute, hour after hour. The logs update normally, no anomalies appear. Normal operation is the highest proof of success. Everything functioning correctly is invisible. Everything functioning correctly is everything. The system blends into the wider factory environment. Nothing about it calls attention. Its stability is quiet, assured, absolute. Engineers walk past, checking routine metrics. Their presence is optional. Downstream, hospital emergency wards operate without disruption. Lives are supported quietly. No one sees the heroism because it is built into pipes, wires, valves, and microprocessors. The system works, and that is all that matters. Redundant systems remain idle but ready. Preparedness without action. Every handover of personnel, every shift change occurs without effect. The system remains constant, unmoved by routine, absence, or fatigue. Time passes, metrics remain steady. Everything continues as it should. The factory hums around it. Production